So I'm going to talk about a project called Foresite. This is a very contrived name, so you can see from the expansion of the acronym, it took us quite some time to squeeze some words into that acronym, but we did it. This is a joint project between the University of Liverpool, HP Labs and JSTOR, and I'm going to tell you a little bit about what the project is and how far we've got and what we're getting out of it. Then go on to talk a little bit about the software development that we've done. We've built some libraries to manage ORE content, and we want to try and get you guys engaged with that. And then go on to talk about the experiments themselves that we're conducting using ORE and these software libraries, mostly to do with building resource maps from JSTOR content, using SORD to deposit ORE into DSpace, and then using DSpace to expose these resource maps in a way that allows you to link back to JSTOR, demonstrating the kind of the pass by reference value of ORE. So, what is the vision? The vision is, in some sense, to bootstrap the scholarly communication process for ORE. So, there's a secondary vision, which is to discover whether we can actually do this with ORE. Is ORE up to the job of describing this kind of content? And part of the project is to feed back to the main project team to say, well, this works, this is clunky, we need to fix this. There are two phases. One is to describe the journals and issues and articles held in JSTOR using resource maps, and then to the second phase to import those into DSpace. And we'll be doing that on bulk. We've got an outrageous quantity of content. JSTOR gave us 6 terabytes of XML, which is going to be quite interesting. So that's because our requirements are we need a large number of documents to describe with ORE. We need DSpace to be able to understand and ingest these, and we need to allow DSpace to link back to the original source. So this is not about ingesting content, this is about ingesting resource maps which describe content on the web. Real pass-by reference. So JSTOR got involved because they have over 1,000 journals. They've got nearly 200,000 issues with nearly 2 million articles. And so, like I say, we've got 6 terabytes of source XML, which translates into around 200 gigabytes of resource maps. So that'll be interesting to see DSpace come to its knees when we try and put that in. This is the approximate outline of the project. So you see on your left the JSTOR repository, which contains lots of domain-specific information, and in each of those domains, lots of journals, and in each of those journals, lots of issues, and in each of those issues, lots of articles, and in each of those articles, lots of pages. Lots of nice hierarchic data here for us to work with. And we use ORE to describe every single level of this process. So a resource map can be used to describe a journal, which will tell us what issues are in that journal, what articles are in those issues, what pages are in those articles. And likewise, we can pull out individual resource maps for issues, describing what's below them, and furthermore, resource maps to describe individual articles. So you get this kind of increasingly granular view of the objects as you expose or dereference more of these resource maps. So we'll be taking this data from JSTOR, we'll be running it through a transformation process. This is run by the University of Liverpool to turn those into resource maps. We'll be pulling them into a local repository, which is just going to be basically a file store with a SORD client bolted onto it. And then we'll be pushing those resource maps into DSpace using SORD and some augmentations that we've written for it. And those items will then be linking straight back into JSTOR. This is just to give you a rough idea, or a more detailed idea of what the JSTOR data looks like. So for each journal, we've got identifiers, titles, publishers. Basically, there's some metadata associated at every single level. At the bottom there, you see the article gets nice and complicated. There's a whole load of different information there, experimental resources, the data, the pages. JSTOR even mark up the individual words and their location in the document. So we've got a lot to play with. Plus, who knows what else. So how far have we got with this? What is the feedback that the project is generating at the moment? So first of all, we're getting into generating these resource maps. We've done the prototyping. We've got some initial serializations. They're not finished yet because one of the big feedbacks from this point is that the atom serialization for ORE is not up to the job yet. So that's a good result in many ways from this project, in that we have tried to come up with a clean atom serialization and are so far still struggling. Hopefully the next version of ORE will have a new proposal for the serialization. We'll see how we get on with that one. But now the development for the main export is underway, and we should have a data set to work within the next few weeks. Meanwhile, we took the decision to develop standalone libraries for managing ORE content. We originally imagined a sequence of style sheet transforms which just went from JSTOR XML to resource maps to SORD to DSpace. I thought, oh yeah, we can just plug that all together. And the more we looked at it, the more we realized that actually almost all of these processes can be generalized, and there didn't seem any point in not writing standalone libraries. So as a native Java programmer, I'm writing the Java implementation, and Rob Sanderson in Liverpool is writing the Python implementation. The aim being that the APIs for both of those libraries are pretty much the same. They're language-specific variations, but basically if you use one, you should be able to learn the other one straight away as well. So we've released some initial versions. We've got a good object model, which I'll show you. We've got some serializers and parsers for various formats. But like I say, Atom is still, there's a big question mark over that. We have an Atom serialization. It's not very good. Then we needed to modify SORD and DSpace to ingest these resource maps, and that basically is done for the project. We've written an ingester, and we'll talk a bit more about that in a moment. And then we need to modify DSpace to manage these ORE resource maps and turn them into DSpace items. To do this, we're leveraging functionality which my colleague who introduced me wrote for the next major version of DSpace, which is to introduce a significant abstraction in the data storage layer. So in the next version of DSpace, it will be possible by configuration to include the intervention in the data retrieval stack to include ORE objects without interfering with the rest of the code base. So I've prototyped that. When the next version of DSpace comes out, I hope that I'll be able to include it straight away. And then I've built a few user interface components as well, particularly an interface to expose all the different kinds of RDF that you'll be seeing used in ORE, and also to embed RDFA inside web pages, and I'll come back to how that's interesting later. And then so we are just at the point now where we're about to start doing some actual experiments to start slinging around plenty of data. That should happen in the next few weeks. So what are these libraries then? Well, this is both the ORE object model in BASIC and the software library architecture. The important thing here is that at the very center is this notion of the aggregation. Now, I'm going to assume that there is not much knowledge about exactly what ORE is here, and talk about this in a little bit of detail. The aggregation is a collection of web resources, all referenceable by a URI. And in that sense, it is the central concept in ORE. It's the singularity in the middle. What you'll find is that these aggregated resources at the bottom, there can be many of them, arbitrarily many of them, all of them described as being part of this aggregation. Likewise, the resource map, which is an XML document, or no, that's not strictly true, a document which describes the aggregation, there can be a number of them. They can be an RDF XML, you can have an Atom one, they can all describe the same aggregation. So in the same way as the aggregated resources, there can be an arbitrary number of resource maps for a single aggregation. Now, every aggregation can have, the triple represents arbitrary data. Absolutely any RDF-like data can be included in a resource map on top of the standard. Likewise, in the top right corner, you'll see the agent. The agent is simply a person record, and basically everything within inside ORE can have a person record associated with it as a recommended property. So again, not required, but recommended that you have creators, contributors, etc., attached to all of your objects in ORE. And then there's this slightly unusual concept of a proxy. We argued long and hard about this, and I think there are still discussions going on over its notion. The idea of the proxy is for reference in context, so that if you want to reference a page in a journal, it doesn't make any sense to reference that page unless you know that it was which page in the journal it was. So the idea of the proxy is to say, I am referring to this page, but I'm referring to it as page 4 in this journal article, not just as a page. So that's represented in the object model as well. Now, I I included some code. I make no apologies. It's fairly straightforward, and I don't intend to talk about it for too long. This is the Java library and how you would go about constructing a resource map. So as I said before, the aggregation is the central thing. So the aggregation is where we start. We have a method, create aggregation. Every one of these objects starting with URI is the URI of the object we're talking about. Create an aggregation with this URI, and then from that you can construct a resource map with a given URI. An aggregated resource can be added to it with the given URI. A proxy can be created inside it with the given URI, and so forth and so on, and the triples as well. The predicate and the object of that triple can be added directly to the aggregation. And all of the objects have similar methods which allow you basically to navigate around the graph that is the representation of these ORE objects. For those of you who are interested, these objects are actually the interfaces, and the implementation is done using Jenna. And the libraries are written such that if you don't like my Jenna implementation, you can write your own and have the dependency injection put it in for you. So what serializations are we supporting? As I said, we're supporting Atom, but still under development, still under discussion. We've got RDFA, and I'm going to talk more about RDFA in a minute. It's a microformat, effectively, for representing RDF, particularly for embedding in HTML pages. And every RDF serialization that our underlying RDF processor supports. So RDF XML, N3, Turtle, and N triples all straight out the box. And you see it's very nice and simple. Again, a little code snippet. It's very simple to create and manipulate these things. If I want to serialize a resource map, I create a serializer for the type of output I want, pass in the resource map. Likewise for the parser, I create a parser for the format that I want, and I give it the file, in this case in the form of a stream of bits, and it gives me back the resource map. It's nice and simple and reasonably quick. So we didn't want to do this in isolation because ORE is a community effort, and we didn't want to do all the work ourselves either. So please get involved if you want. There is a website which will tell you about the project. There is a wiki which is not only about the project but about ORE development in general. All of the software, both the Python and the Java libraries, are available in this Google Code repository. And we have a Google group as well for discussion. There's only a few people who are members at the moment, so I encourage you all to come and join us and tell us how you get on with the software. I presume these slides will be made available somewhere. Will we be able to get to those? Okay, good. I'm getting a thumbs up from the back. Okay, so a quick word about SWORD and ORE. SWORD has been mentioned lots. It's getting loads of press, so I won't spend too much time saying what is SWORD. So SWORD was a JISC-funded project, and it was a profile of the Atom publishing protocol. In the simplest case, the repository publishes a service document which explains where you can deposit to, and a client will post documents, zip files, packages to that URL, and the repository will ingest them and return with a success or a failure notice. And in a slightly more complicated case, you can actually post on behalf of other users as well. I won't talk about too much. So there are three ways that you might imagine embedding ORE into SWORD. The first of these is the ultra pure pass by reference, which is that instead of passing a package at all, what you pass is the URL of the resource map that you want, that describes the thing that you want to ingest. So you pass that to the SWORD server. The SWORD server dereferences the resource map, opens the resource map, dereferences the content possibility. The second case is that you pass the resource map as the package. So our resource maps, for example, can be generated on the fly, so there is no URL to pass by reference. So we pass the resource map, which then is interpreted, and you can dereference the content if you like. And the third case is to use the resource map itself as a package manifest. It works just as well for referencing local content inside a package as it does for referencing content on the web. I put the second one in italics because this is what we're doing for our project. As an aside, Richard Rogers from MIT has done number 1, and we're going to combine the code so that we have 1 and 2 covered by default, and I hope that that will be included in a SWORD distribution, certainly for DSpace in the near future. So, oh, I'm moving quite fast. Okay, I'll slow down a little. Okay, sure. Mm-hmm. Excellent. Oh, they might do 3 for us. Excellent. So, I guess the exciting bit, at least from my point of view then, that's the kind of the background, that's where we're coming from, that's what we've been working on. This is, how does this work for DSpace? And I know this is not a DSpace user group meeting, but I'm going to talk about it anyway. How is ORE, how can ORE be used inside DSpace? How can we take this stuff that we've done so far and turn DSpace into an ORE compliant, whatever that might mean, application? So first of all, we have to make our augmentations to sort. So we add the new ingester, the mechanism which can do operation number 2 on that list I showed you earlier on, to take a resource map and turn it into a DSpace item. Then we can store that incoming resource map, so that's just a file. And then we do something a little bit special, which is we pull that resource map open and we add or we decorate it with our own DSpace specific things. So DSpace assigns identifiers to everything that's in the archive, and those identifiers need to be part of this resource map now, because this resource map can be identified in new ways. So we add a few more identifiers, we localize it to the DSpace install that it's been put into, and we store that in a canonical form. So this is an arbitrary decision, but I like RDF XML, so I store it in RDF XML. And then we also examine that resource map for any scraps of metadata that are available. So there's author information in the metadata for the resource maps, there's title information, there could be other less obvious but recommended metadata, so we check for things like abstracts and so forth, and populate as much of the DSpace metadata record as we can as the resource map comes in. And that's all we do. We don't ingest the files. We don't try and do anything particularly cunning with it. We simply store these resource maps as files that have gone through a little bit of transformation using our source libraries, our Foresite libraries. So how do you interact with such an object? It's not that much use, at least it didn't seem to me, to be able to go to this DSpace item and instead of being given a list of the PDFs, be given a list of the resource maps, and you'd have to open them up and find the PDFs yourself. That's no use at all. So what we actually do, and this is a cunning trick, those of you who know a little bit about the underneath of DSpace will understand a little bit more what I'm saying, but we store the resource map in a special place inside the item called a bundle, and I have a specific bundle in which I put all my ORE-related materials. And then, using the intervention in the data access layer, I open up that bundle when an item's files are requested and fake the DSpace item by reading in that resource map and turning them into what looks like DSpace files. And then I send that fake item to the user interface for rendering. So the rest of the application never knows that anything is unusual about this item. And in fact, the good thing about it is with the next version of DSpace, you'll be able to simply do this in configuration to say, if there is an ORE object, then use this intervention method to render the relevant item. I can't show you a demo yet because we're not quite ready, but I can give you a little bit more of a graphical description of how this works. So you see you get a request for the item retrieval mechanism will, instead of talking to a file system, talk to a localized resource map. We'll turn that into an item, and the DSpace item will be sent to the user interface. But you see the files that the DSpace item has are actually not real files at all. They're simply links to the files that exist in JSTOR. So in that sense, DSpace is actually a repository only of resource maps, but the user interface is presenting a traditional archive. Any questions at this stage? Because I'm going to talk about identifiers briefly, against perhaps my better judgment. No? Okay. So there's a sneaky issue which creeps in when you start to talk about resource maps and identifying objects in archives. And the question is, what is the identifier actually identifying? Your URL for your repository may include a fragment which is the identifier of the object you're talking about, but it will be in a URL. And the question is that URL the identifier of the object, or is it the identifier of the splash page, or is it the identifier of the resource map? And is there a difference? And how do we resolve the differences between those three possibilities? The way that we've chosen in Foresite to interpret this is that the fragment in the URL is the identifier of the digital object. And the URL itself is a mechanism-specific method for retrieving that digital object under a given set of circumstances. So to retrieve the identifier from a DSpace user interface is to say, please give me the splash page representation of this object, which is what you get. Now, the problem with that is that it's very difficult to get from that human-readable splash page, which is the traditional page which people cite, to the machine-readable pages and the digital object. So we scratched our heads for a bit, and there are a few suggestions in the ORE community as to how to go about this. But I think we added a new one, which I will talk to you on the next page. But basically, we certainly insert link tags into the headers of the user interface now, so that if you retrieve a DSpace splash page, there is a link to all of the possible serializations of the resource map for that page. And it's tagged rel equals resource map, so you know what you're looking for. But there's another cunning trick, which is that what we actually do is we turn the splash page into a resource map in its own right. And we do this using something called RDFA. Now, RDFA is a slightly tricky hack micro format, which has been used reasonably extensively recently to embed semantic data in web pages. And traditionally, it will be scattered throughout a web page, describing perhaps a document with links in it will be marked up using RDFA, which is a non-rendering format, but which can provide semantic markup to your content. Now, to produce those electronically by machine is virtually impossible because it requires a semantic understanding of the page, which we don't have. But what we can do is we can produce a non-rendering block of XML, which is valid HTML, which can be embedded inside a splash page, so no one will know it's there, apart from a machine which understands that it's looking for it. And so this is how it's done. I don't know how many of you are HTML aficionados, but it uses divs, which are HTML structural elements, and spans, which are also inline structural elements for HTML, and anchor tags with no content. Now, let me point out the hack for those of you who are interested in this thing. These blank anchor tags are technically incorrect. They ought to be it ought to terminate with a simple slash close angle brackets without the end tag. But unfortunately, HTML browsers render that as a link which covers the rest of the page, which is no good. So there is a hack. I do apologize, but we did our best to get around it. But this doesn't render at all. There's no page impact on this particular fragment. What it does mean is that if you pass the HTML splash page from a DSpace repository to an RDFA-aware ORE application that maybe is backed by a Java library that I wrote, it will be able to pull the resource map out of the HTML page. So we solve the problem of what is the identifier for the resource map by making the splash page and the resource map the same thing. Meanwhile, to do things properly, our link tags in the headers of the DSpace pages all lead out to the standard serialization. So what we actually have here, I'm nearly done anyway. So what we actually have here is some plain RESTful interfaces, effectively, to the different serializations for that object. So in the same way that we interpret the identifier fragment in the user interface page as being the identifier of the object and the user interface URL as being the mechanism by which we access that identifier, we do the same here. We're saying to access the atom serialization for this object with the handle 123456789/100, pass it to the atom URL. To do so, to get the n triple serialization, pass it to the n triple URL, and so forth and so on. And so these are the 5 serializations that we currently support using Foresite. Aside from the atom one, they're all a product of the fact that the underlying RDF library generates these for free, so I can simply ask it to give me all of the different variations. There are a few more that it'll do, which I haven't included on here because they seemed a little bit more esoteric. So that is a whirlwind introduction to Foresite and the stuff that we're doing. This stuff will is all available open source. The DSpace stuff is not yet available because it's not quite finished, but will be available quite soon. It's being built as a module, so it'll be releasable separately from the main distribution of DSpace. And we are due to finish in September, so hopefully by then we'll have built a bit of a community around the libraries that we've built and seen a few more people have a go at using them. So thank you for listening to me. I'm Richard Jones. This was a presentation about Foresite. Thank you.